This unit is going to be on scale diagrams. So a scale diagram is a diagram that is an enlargement or reduction of another diagram. So where is this used in real life? Well, you use it all the time on your cell phone when you enlarge or make pictures smaller so you can see them. We also see it in blueprints, photography, architecture, carpentry, engineering, manufacturing, and a lot more. So it is important. Scale factors. The ratio of a side length of a shape compared to the side length of a similar shape. Or maybe a bit easier to understand, what would I multiply the side length of one picture by to get the side length of a new picture? So let's take Dirk Nowitzki as an example. So I have my first picture here is 10 centimeters by 15 centimeters. My image here is 30 centimeters by 45 centimeters. So the scale factor, or what I would times this one picture by, would be times by 3. And I would get 30 and 45 centimeters. So the scale factor in this case is 3, because that's what I multiply by the side lengths. Now I have to multiply both the sides, the width and the length, in order for it to be a scale diagram. So, taking another example here. Okay, if this is my original, this is my scale diagram. So I made an enlargement, I made it bigger. Okay, I need to figure out by how much though, what my scale factor was. So what I'm going to do is I'm going to take the length of the side of my scale diagram and divide it by that corresponding side on my original. Okay, so I would take 50, divide it by 20, I would get 2.5. Now I need to do the same thing on the width of my picture here with 25 and 10 to make sure that they have the same scale factor. Otherwise, they aren't scale diagrams. So I would take 25, divide it by 10, and I would get 2.5. So that's a good thing. It needs to have the same scale factor for it to be a scale diagram. So that's how you find the scale factor. Okay, make sure you match side lengths on the original with the side lengths on the scale diagram, the corresponding lengths. So we take the length on the scale diagram and divide it by the length on the original diagram. Okay, that's how you find the scale factor. So you need to remember that. The scale diagram divided by the original diagram. And the scale factor, it can be a decimal or a fraction or a whole number. So if the corresponding lengths have the same scale factor, we say that they are proportional. So let's look at this picture of the mosquito. The actual length of the mosquito is 1.5 millimeters. Determine the scale factor of the diagram. So the length of the picture is measured at 4.5 millimeters. Okay, so the picture is 4.5 millimeters divided by the actual, so 1.5. So this would give me 3. So my scale factor is 3 on this one. If a scale diagram is smaller than the original diagram, it's called a reduction. So we were doing enlargements. This one would be a reduction. Same formula for it, length on the scale diagram divided by length on the original. The only difference is your scale factor is going to be less than 1. It's going to be a fraction or a decimal, because multiplying by less than 1 will give you a smaller number for your reduction. So if we look at this picture, let's find the scale factor. Okay, this is my original here. My scale is this other one, so I've done a reduction. So what I'm going to do is I'm going to take this side and this side, I'm going to use that. So the formula for the scale factor is the scale divided by the original. So So that would be 8 centimeters over 24 centimeters. So match up corresponding sides. Okay, I could simplify that to 1/3. And I'm going to make sure that this one is 4 centimeters over 12 centimeters. That's also 1/3. This is a repeating decimal, so it's better to leave it as a fraction, but you can see that they are the same. So that's the scale factor, is 1/3 on this reduction. So we can solve problems with the scale factors now. Okay, given that two objects are similar and given the scale factor, you can find different side lengths. Okay, so the side length of a room on a blueprint is 5 inches. In order to enlarge the drawing to real life, the scale factor is 4. So 1 inch could equal 4 feet. What's the actual length of the room? So since the scale factor is 4, on the blueprint is 5 inches, I could just go 5 times 4. In actual life, it would be 20 feet. So let's just do a couple examples. This photo needs to be enlarged by a scale factor of 9/2. Okay, you could also say 4.5. The dimensions are 25 centimeters by 45 centimeters. What are the new dimensions on your scale diagram? So we're going to take the original dimensions, the 25 and 45, and times it by the scale factor. So 25 times 9/2 would give you 112.5 centimeters. And 45 centimeters times 9/2 would give you 202.5 centimeters. So those are the new dimensions. If this is the image and you have the side length, you can take the length of the image and divide it by the scale factor. So this is going opposite. Let's say you have the image, you want to find what the original dimensions are. So I would give you the image, which is 24 centimeters by 18 centimeters, okay, and a scale factor of 6. So I'm going to find the original, so I could go 24 centimeters divided by 6, I would get 4 centimeters, and 18 centimeters divided by 6, I would get 3 centimeters. So those are the dimensions of the original. You could also do this to draw a new shape. So if I had this star and each side is 8 centimeters, scale factor is 0.25, so I'm doing a reduction. So I could go 8 times 0.25, and that would give me 2. So each of my side lengths on my new star that I draw are going to be 2 centimeters. So that's scale factors and how we can use them.